going to send along with this parity bit. Then I'm going to send that parity bit with the actual code word to our receiver side. Okay, our receiver side, because I have to send anything to receiver, we need some of the transmission media. Okay, here I am going to use here transmission media. Okay, through that some of the transmission media I am going to send all the data toward the receiver side. Our receiver side, what it will happen, okay, it is going to collect. So here I'm going to say it as a B0, B1, B2, B3. Okay, because as a center it won't confusion. So because of that only I'm going to name it as a, this side has a B0, B1, B2, B3. Okay, here whatever they have taken, whatever the receiver or whatever they taken from the code word from the sender side, that code it is going to again send to our checker. Okay, here our checker, it is going to check whether the given parity, okay, whether it is the given code word, it is the even parity. So our syndrome will be 0, means our resultant value will be 0, otherwise it become 1. Means if it is not even parity, okay, that result will be 1. So that during that time our decoder, it is going to reject it, means it is going to discard it, because our aim is, if it is the even parity, I have to accept the result at the receiver side. Okay, if it is not, okay, it is going to discard it. Same thing, if it is even parity, it is going to accept the particular data at the receiver side. If it is not, it is going to discard it. The next one is, see, this is the what the next one is cyclic code redundancy. The cyclic code redundancy, the first aim of the cyclic code redundancy means we have to detect, we have to correct the errors, but our redundancy means we have to do both the cases, means we have to detect an error, both we can do it at the redundancy process, but our cyclic redundancy code, only we have to correct the errors. Okay, this is the major part of our cyclic redundancy codes. In this schema, if a code word is cyclically shifted, the result is another code word. Means, see, this is what I am going to consider as a B1 is equal to A naught, and B2 is equal to A1, B3 is equal to A2, B4 means this is what our code word is cyclically shifted if the result is another code word. Okay, then this is what our crc generator and checker. Okay, see, I told, right, in sender side our data is there, along with that I am going to add some extra bit. Okay, that bit I am going to call it as a n bit, means this is what our code word. Okay, this is not a data word. Okay, this code word I am going to add it with our actual message or actual data, that it is going to send it to our divisor. Okay, divisor here n plus 1 means along with that code word it is going to add it many number of bits. Okay, then finally if it is not equally 0, okay, if it is not completely executed whatever the given word, whatever the given data and along with our code word, okay, if it is not equally completed, or if it is not divided completely, okay, then it is going to show some quotient. Okay, then during that time our data will be discarded. Okay, if it is completely divided, okay, our crc means cyclic redundancy code, there is no any errors. Okay, it is not found any errors, it is easily sent to our data with the receiver side. Okay, our receiver side, if it is any remainder is there, okay, if it is any remainder, if it is, sorry, if it is if it is not any remainder, it is easily accepted. Okay, if it is any remainder is there, it is going to reject the data at the receiver side. Then see, this is what our CRC code. Okay, this by default they have given the data word. Okay, this is what data word. For this data word they have given the, this is the what the code word. Means if it is 400, the data word should, sorry, the code word should be 8 zeros. Okay, if it is 001 has a code word, our data sorry, if it is 001 has a code word, our if it is 001 has the data word, our code word will be 001011. This is the by default or manually they have given. Okay, based on that we have to solve the problems. Okay, see, this is what our design of CRC. Okay, see, our CRC I told, right? If it is the sender side, if it is the data word, okay, I am going to send along with the extra bit, means extra n bit. Okay, see, this three zeros are the extra bit I am going to send. Okay, our generator, it is going to generate the reminders. Okay, that is nothing but r0 r1 r2. Okay, that is r0 r1 r2 is here nothing but the our redundancy bit. Okay, along with that redundancy bit, our code word it is going to established, means our code word will be going to generated. That code word it is going to send to receiver part. Okay, your receiver part, if it is fully divisible, it is going to accept it. Okay, if it is not able to devise that particular given data word, okay, that should be rejected. So this is what our CRC design. But the one thing I am going to tell for shortly what is the CRC will do means, okay, whatever the data is they have sent from the data word, okay, as a sender, okay, we have to completely we have to use without any finding the errors. Okay, during that time your receiver it is going to easily accept that particular data. Okay, if it is any error will be occurs, okay, that data it is going to reject it. So this is what our aim of the cyclic redundancy code. Then the next one is, so this is what our division of the CRC encoder. Okay, so I have taken one small problem. So this is what I have taken one small problem here. So this is the data word, okay, 1001. Okay, the 1001 has a data word. Okay, I'm going to taken the 1001 along with the three extra bit. I mean, this is the three extra data word I'm going to add it. Okay, because why I'm going to add it, because I want to find out the actual data here, means actual correct divisible, completely it is going to divisible data. So see, this is the divisor 1011. From this I am going to divide the data word. Okay, I'm going to see, I'm going to divide it now. Okay, 1 plus 1 it becomes 0, again 0 plus 1 it is 1, again 1 plus so 0 plus 0 if it is 0. Here why, because I am always like leaving the leftmost bit here, means if it is 1, okay, it should be a error, means this is not a odd parity. Okay, this should be a even parity. Okay, so that I'm going to, okay, if it is 1 1 also, okay, finally I got 0 only. Okay, then again I am going to add now one more extra bit here. Okay, see, you have to do again or operation. 1 plus 1 0, 0 plus 1 is 1, and 0 plus 0 is 0. Okay, again finally at the end we got 0, but he got 1, so we got 1 here, so that I cannot add the 4 bit extra 4 bit 0 has a divisor. Okay, see, once we got the leftmost side 0, so I am going to easily add the divisor as the 4 bit 0. See, I am going to add it here 4 bit 0 along with the extra bit. Okay, again I have to do the or operation. Okay, again see, here also we got one more time also leftmost bit has the 0 here, so that again I am going to add the 4 zeros. After that again I am going to and like do the XOR operation. Finally I got the remainder, so 0 1 1. See, this 0 1 1 I am going to add it with the actual data word. Okay, see, this is what data word. Okay, this is what resultant word I'm going to call it as a code word. So this code word it is going to finally receive as the receiver. So this now we can able to see, right, how is the division will be happens in the CRC encoder. The next topic is data link controller. So the data link controller, like you know that what is the data link? First of all, it is going to do, it is going to controls the frames, because whatever the data I am going to send in the form of frames. Okay, here frames is nothing but it is a